This is our final bit. Our final bit of research methods. How scary. If there is anything you are unsure of, email me and we can discuss if you don't understand any of it or you just you just don't know what to do. I would rather that than you sit there, suffer in silence and then struggle. Okay, so this final bit is called Features of Science. So it's an old age debate. Is psychology a science? The answer is no, because we can't fully prove anything in psychology. We're a social science. We work with people. But there's people that argue that we are moving in the direction of becoming more scientific. We need to know the key researchers and the debate. Start with a quiz to recap. 6 questions here. What did later psychologists... what did they reject? Event. How do we assess validity? They love those questions. Binding factors. What are binding factors? Context-dependent forgetting. Who supports that? Method of assessing strange situation. Why is it biased? And then the cognitive characteristics of depression. So use these to guide your revision. They later rejected introspection. That whole looking into isn't scientific and testable. We assess validity by looking at face validity. So on the face of it, it seems to be okay. And concurrent validity. And what did it do for concurrent? This one, potentially, where you compare your measure against something else. Binding factors are elements or things that allow people to sort of punish someone else and ignore their behavior. So it's like they deserved it kind of thing. Supports context dependent. It's gotten them badly with our divers. If they learnt the information on water, recalled it in water, did better. In method of assessing strange situation is biased because Western. It's imposing a viewpoint from the USA across the world. So it's called imposed ethic. And the cognitive characteristics are how you think when you're depressed, poor concentration, negative bias, and that absolutist thinking, very black and white. Okay, so is psychology a science? The features of science. Excuse me, sociologists, some of this will be like you kind of already know it, because the psychologists and the sociologists are the same people and have the same principles. So they're not necessarily psychologists or sociologists, but they share the same ideas. So what are the features of science? So what makes something scientific? How would we know that something is or isn't scientific? So it's things like, if we think about it in psychology, what studies have we looked at that can we define as scientific? And then have we got any approaches that are deemed to be scientific? So hopefully you're thinking anything in the biological approach, we would say, is relatively replicable and reliable. But as far as our other approaches go, apart from cognitive, some of them are a little bit flaky, aren't they? Keywords that we're going to need for this section. So empirical, objective, replicability, theory construction, hypothesis testing, falsifiability, and paradigms. Now, in the workbook, they're all there if you want to go over summer and create a lovely glossary of key terms for research methods. That would be a lovely thing to do. Some of them you're not going to understand, but by the end of this, you will. So the old age debate, 2 strands. The first looks at whether psychology in its present form right now meets the criteria to be a science. Some people say 100% it does. The second is that we should be striving to be scientific, but we're kind of a pre-science. We're not there yet. And there is actually, no, don't worry about that. Yeah, that's fine. So science, what is it? In science, you've got to have a definable subject matter or paradigm. So a paradigm is basically a set of ideas that everybody agrees on. So if we think of a paradigm, something like gravity, we all agree exists, and it's a subject, you can define it, you can measure it. There's got to be a theory constructed from hypotheses which are derived and tested. So someone has a theory. For example, our emotions are universal. So you'll see happiness, sadness, all across the world. That's a theory. They then create these hypotheses to test the theory. Concepts must be falsifiable. Now, falsifiability basically means that we can test it to try and prove it wrong. If we prove it wrong, then it's not credible at all. If we can't, but people still try to, then we are trying to test this idea of falsifiability. Is it true? There's got to be a use of empirical methods. Empirical methods, just means testable, reliable, measurable. Testable, measurable, same thing, on which that it can be investigated. And then there's got to be a set of general laws that govern behaviour. So it's called normothetic, and we'll look at that in year 13. The behaviourist approach is normothetic because there are a set of ideas that we all agree on with operant and classical conditioning. They're still seen today, they're still used. Okay. Why is a paradigm important in science? So a paradigm, like we said, agreed set of assumptions about a method. Now, Kuhn is one of our key psychologists here. So we've got Kuhn and we've got Popper. And they have two different ideas of psychology being scientific. So he's arguing that a subject can only be called a science if there is an agreed global theory. So evolution, all biologists accept that exists. That is a theory. Gravity, we've already come up with as well. And there are 3 stages of something becoming a science. So pre-science is where some people think we are, which is there aren't really any paradigms that exist. Nothing is so concrete that everybody agrees. Normal science, biology, chemistry, physics, they can account for some of the accepted paradigms within their fields. And then a scientific revolution is where we have the old paradigm and a new paradigm. And there's lots of evidence that goes against the old paradigm, which means we have a paradigm shift and the new paradigm replaces the old one. So if we think of something like, it could be evolution or gravity, people thinking that it didn't exist, and then we have this new paradigm come along, completely washes that out of the water. Theories are important in science. So a theory is a general set of laws that are there to explain an event or a behaviour. And scientists believe that events in our world, they're not random. They can be ordered and predicted. So order and direction are really important when it comes to theory construction. They organise the facts and they create predictions about what could happen. So they're the basis for research. We gather lots of empirical data and then we go out and we test it. There's 2 ways of doing it. So you've got the theory, hypothetico-deductive model, which is this one, where you start with a theory, you have a hypothesis, you go out and observe it, and then you confirmed it. Or the induction method, where you start with a bit of observation, that then creates a pattern. You then create some vague hypothesis, which then confirms a theory that you have. So there's two ways of doing it. So deriving new hypotheses from an existing theory is called deduction. So the hypothetico-deductive model would use that one on the left. Something like, what would be, taking a general area and making it specific. Just trying to think. Something that we've looked at. So if we take like the behaviorist approach, the theory in operant conditioning is that by creating positive and negative reinforcement, you're going to change behavior. The more you go out and test that with children in prisons, the more that supports that theory. If hypotheses are not and predictions are not confirmed when tested, so using lab experiments, something objective and reliable, then the theory needs to be reconsidered. Does it really exist? Is it something that is relevant anymore? So a couple of questions here. Explain the role of theory in scientific research. You've got a couple of ideas to help you there. And one role of hypothesis testing in psychology. I have the answers for you to have a look at after. Okay. Oh, actually, yeah. So when we talk about the features of science, what we've now looked at is what science is, how science develops from pre-science to a revolution. There are various areas on the spec that they want you to look at for features of science. So they want you to know objectivity in the empirical method, replicability, falsifiability, theory constructions, and paradigms. We very briefly touched on them a minute ago. So he's going a bit more depth. So objectivity and the empirical method. They have to be unbiased, objective in their investigations. Keeping that distance allows them to maybe see it clearer than if they were muddled up and involved. No bias can come to discolour the data because then you're not really getting anything that you can reliably use. Lots of control in things like lab experiments. Those methods are really important. And then just a quick comparison if you weren't sure on them. Subjectivity is all about people's own viewpoints. Facts, personal views rather than facts compared to objectivity. So the empirical method, objectivity is the groundwork, is the basis of that method. And what it basically means is that we have to emphasize data collection being as precise and accurate as possible. So things like using a lab experiment is an empirical method that will produce objective data. So a theory cannot claim to be scientific if it hasn't been tested empirically. So things like in memory, the idea of the working memory is now a thing because it was tested in labs, because it was done in a way that is more valid than an observation. Replicability is nice and straightforward. All it is doing something more than once to make sure that it is consistent within itself. And replication or replicability has a really important role in the validity of findings, so how accurate they are. So the more that you do an experiment, the more accurate the data will be. Which means you can generalize it in lots of different situations. How can they ensure that they are replicable? Well, falsifiability comes under that strand, which is where we have to test as much as possible to try and prove something wrong. So Karl Popper is all about falsifiability. He's like the opposite of Kuhn. And he said the key criterion of a scientific theory is for it to be falsifiable. So it should hold themselves up. They should be held accountable and tested over and over again to eliminate the possibility of being proven false. So his whole concept was you cannot say that all swans are white because you need to go out and test it, because if you come across a black swan, then your whole theory is completely eradicated and disproven. So whenever you have a scientific principle that has been successfully and repeatedly tested, it doesn't make it true, it just hasn't been proven false yet. Ah, there he is. So he drew a clear line between good science, where theories are always being challenged, like in behaviorism, and pseudoscience, psychodynamic, things that we can't test which can't be falsified. So those theories that have the most attempts of being tested are the strongest and the more credible. Doesn't mean they're definitely true, they just haven't been proven false yet. That's why whenever you write "this proves," I cross it out, because nothing has ever been proven. It's always, it seems to suggest, because then they're adding more evidence to the theory. Okay, theory construction and hypothesis testing. Science tests theories, but what actually is a theory? So like we said before, it's a general law of behavior or events that we test. So that theory construction takes place through that gathering of evidence using empirical methods. So I've got an idea, long-term memory has a duration of up to a lifetime. We know that's true now. Based on the observation that when even the elderly have memories from when they were young. I'm going to do a series of experiments that support this. I'm going to give them some cues. So my idea can be Farnsworth's law, something like that. It should be possible to make clear and precise predictions on the basis of a theory. And an essential theory is that it can be tested with a number of hypotheses to put that out there. So something like people who learn to ride a bike as a child remember how to ride them even after 20 years. We can test that. We can get people out there on their bikes constantly, whole different age groups, to see whether or not we can support or refute it. That's then supporting the theory and strengthening that. It's making it more generalizable, more accurate. And if it goes against it, then we need to revise the theory. Maybe it just isn't true anymore. Okay. Yeah, the scientific method, lovely. Right, paradigms then. So old Thomas said that what distinguishes a scientific principle from non-scientific is the paradigm. So paradigm is what students don't really understand. It's just a set of assumptions that we all agree on. Whereas he also said that psychology lacks this universal idea that we all share, so it's a pre-science. Now, so having looked at all the features that constitute a science, we're going to see whether or not it is or is not a science. A little program there for you to have a look at and to watch to really deepen your understanding of this section. And then, what's your personal view? Do you think it should be a science? Do you think it shouldn't? The key bits here are knowing what those two psychologists say, understanding all those key terms and how you could use them. A type of question, I don't think they would ask you to bring in other areas of psychology to back it up, but always good to have a little backup just in case. But that's it. That's research methods finished. So over summer, sharpen yourself up. Get yourself in a position where we're not going to have much time to go over year 12 content. So make yourself in a position where you've got some good revision to go on. We'll come back. We're doing issues and debates, then biopsychology, gender, schizophrenia, forensics, 5 topics, and then we are done. Okay, so have a lovely summer. And if you do have any worries or queries or anything you want to go over, just pop me an email.